So in case you can't tell, I'm a Captain America Cheetah-Unicorn, because that's what Catherine asked me to dress up as today for this special meeting. So she got to dress up. Today, I hope that we're going to have a little bit of fun, but actually also going to I'm going to challenge myself to challenge all of you to actually learn a bunch while we're having some fun along the way. I have a confession to make. Part of the reason I'm doing this this Halloween themed event here the week before is because I'm feeling tremendously guilty. I was honored to get the announcement that I was selected as a fellow into the American College of Medical Informatics, which is very exciting, and I'm very flattered to receive that and to get recognized. However, the ceremony for the induction is actually on Sunday, October 31st, which is Halloween. And as the proud papa of a 5-year-old daughter who loves Halloween, I've been feeling very guilty about having to miss that. So we've been trying to have a lot of fun with getting ready for the Halloween season, and I'm trying to just celebrate Halloween early since I won't be able to do it in person with Catherine in a couple days. So when you see this picture, what do you all see? Anybody can shout out whatever you see.
Pumpkin.
It's bent.
It's a pumpkin. I agree with that. Pretty demented pumpkin, right? It's all screwed up.
Japanese kanji, but not sure what it means.
Oh, a Japanese kanji. Nice. Very good.
Good scar.
Well, when I went with my daughter to go pick out some pumpkins, we looked at this and we said, that kind of looks like the OHDSI logo. You got kind of like, you got the 45-degree line there. You got like a hint of a little arrow there. You got the line. The only thing that's needed is to take care of decorating this pumpkin. So that's what Catherine and I did this weekend. Here is our pumpkin. You can see with just a little bit of touch up, we're able to make that match up to our community pretty nicely. And even at night, it actually looks pretty good. We can see our OHDSI logo sitting proudly on our front stoop here. And you know, because it's pretty rational that you'd have lots of decorative Halloween spirit things, but that you'd still have an OHDSI logo in the middle of your pumpkin collection. So I just wanted to share with you all that trying to mix a little fun and family times here. So that's my pumpkin that I wanted to share with y'all. Also, as a parent of a 5-year-old, this is the season when we get excited to do fun things like dress up and run around and get candy for those who are in places that want to do that. But this is also the season of 2 weeks of irrationally silly and stupid news articles that come out warning you about all the dangers of Halloween. And so just in the last couple days, I've had to read articles about Halloween. Is it actually safe? Particularly, is it safe to celebrate Halloween in the COVID-19 pandemic? You know, there's USA Today asking you whether or not it's going to be okay to celebrate Halloween amongst a pandemic. You then get the annual ritual of stories saying, well, the real danger about Halloween is something else. And usually you read these articles about increases in traffic accidents and dangers to kids, as well as you hear about how Halloween is become America's most dangerous holiday, including going all the way back to the folklores of people poisoning candy and putting razor blades and apples and all sorts of silly stuff. So while I think this is a great holiday to celebrate, I also have to deal with the fact that I tend to be a fairly conservative person and don't want to put my daughter at risk. So I thought I could perform some analysis on our data to actually quantify the risks associated with Halloween. And so my objective today, and I've got exactly 45 minutes right now, in 45 minutes or less, I plan to get 80% of you all to have learned at least 3 or more new tricks using OHDSI tools. And then hopefully those will be a treat that you'll be able to carry on, not just for this silly analysis that I will design and run live in the next 45 minutes, but also for all your real research that you're going to be doing for something hopefully more impactful than this. So I'm going to keep you all on your honor system, but I've just released a poll in our meeting. And I'm going to keep this poll live throughout the entire meeting. And I'm going to ask that you are updating your own response to this poll throughout the time, so you can keep changing your vote as you go. The question is going to be, how many new tricks were you treated with today? And it's totally okay if everything I show you is something you already know. That means you're just an Odyssey whiz and you know all of our tools, and that's great. But if you pick up one trick, I want you to mark 1. If you pick up 2, 3, 4, maybe even get 5 or more treats, and you say 5 or more tricks that you learned today. Now, my hypothesis is that even though many of you on this call, I can see that there's already, there's like 160 of you on this call right now. Many of you are well versed in our Odyssey tools, but I suspect that at least some of you could probably learn some of the new tricks and features and available things that are within our Odyssey ecosystem, maybe just because you haven't ever gotten around to check those out. So what we are going to do for the next 44 minutes is use our Odyssey tools to ask questions about what about the health of kids for Halloween. All right, so first of all, there's a lot of tools that we could be using. Today I'm going to use a few of our tools as a hope to try to teach you all new tricks. I'm going to use Atlas and various features within Atlas to be able to create some cohorts and perform some characterization analysis. I'm also going to show you an instance of cohort diagnostics, which is a tool we use to develop and evaluate phenotypes. And I'm also going to use ARIES as a way to characterize a database to understand what's actually in there and what we can study. Now, already, for some of you newcomers, if you haven't heard the phrase Atlas, cohort diagnostics, or ARIES, then I might have already taught you a trick, but hopefully you'll actually see what you can actually do with that information. So first things first, Halloween is on October 31st. And so if I was interested in trying to create a cohort of people, I might be interested in people who exist in our database on October 31st. Now, typically when we think about creating cohorts in Atlas, we typically think about creating cohorts that are based on people with a disease, people with an exposure. Much less commonly, do we actually see people creating cohorts that are basically defined on some calendar time. However, if I go into Atlas and I click New Cohort, I'm going to show you how I could create a cohort of people who belong to the database on Halloween. So we're going to do, let's see, Halloween, people in database on Halloween. And this is a feature that not very many people actually use, but when you define it, whenever you're defining a cohort, you have to define a cohort entry event. And the question becomes, where do you put calendar time in an entry event? And here we can use our observation period as an entry event. And when we do that, we can actually specify a start and an end date for the duration of time that someone needs to be in the database for us to be able to follow them. So I can just say I'm interested in people who were in the database on Halloween, October 31st of last year. And in this specification right now, anybody who was observed in the database on October 31st, 2020 is going to be in my cohort. Now, if I'm interested in characterizing those people, I might want to have some sort of follow-up time associated with those people. So I can specify some minimum number of time that they're observed. So I could say I want them in the database for at least a year. And I could also say that I want those people to be observed for some follow-up time after that date. This is no different than any other cohort we're doing. The only difference now is that the index date is now this calendar date of October 31st, rather than being the moment of a diagnosis or a drug or a procedure like we typically do. Now, I'm particularly interested in Halloween, so I could also further specify an age group. So I'm interested in kids. I'm interested in worried about Catherine. So I might specify an attribute, which is age in years at period start, and that I could specify that this period start is referring to the observation period start, and I could specify an age there. So I could say at the start of their observation period that they were, say, between 5 and 11 years old. That's one way I could specify an age. Another trick that we can actually use, though, is to actually specify an inclusion criteria. So I could say people must be age between 5 and 11, in which case I can create a new inclusion criteria, add an age criteria, specify that it's within 5 to 11, and I've got a cohort now. I'm going to check my poll to see if I've given anybody a new treat or a trick that they might not have known before. Let's see. Hopefully the poll is going to pop up here on the screen so I can watch to see if and when I've provided anybody some new insights. So view results. All right, so half of you have already learned one new thing, and actually a couple of you have learned a couple. Great. And that was only 4 minutes into this. Great. So I've now created the cohort that I may be interested in. And in this particular context, all I cared about was that people were in the database for some duration of time. They're on Halloween. Now that I have created this design specification, I could use my use Atlas to generate on whatever databases I have access to. And in Atlas, if you have a network of databases available to you, then you will see many different databases available. You can see in my particular instance here at Janssen, we have many different databases available. And one of the things I'll highlight that is a best practice that we are trying to follow at Janssen is that we want to make sure that when we refer to our databases, that we version our databases. So for example, I'll just pick something arbitrarily here. The Optum SES database, you can see that we have this version number 1680 and this version number 1706. This is for us to keep track of the versions of the databases that we use in our analysis. Each time we receive a data refresh from the vendor in this particular case, we need to make sure that we version that off. This allows us in this particular case to be able to look across different instances of the database and try to maintain that. This can be difficult for organizations who are like running out of server space to hold on to databases. And you can see here, for example, we only maintain a couple connections to databases at a time because we don't have all of the provenance of all the prior versions just loaded up here in Atlas. But for any database instance that I'm interested in, I can go ahead and just click generate. And that is going to call out to take this cohort specification that we just clicked through. It's going to, on the export tab, I will show you. Come on. Slowly, I will show you. On the export tab, you can actually see human readable text that describes the cohort that we just created by clicking through buttons. That's particularly helpful if you are in the process of designing a study and you want text to be able to populate a protocol, for example. We encourage you to use that. Those buttons you clicked ultimately produce a JSON specification. This JSON specification can then be translated into SQL across a wide array of dialects. Our Odyssey SQL is our default language that we use to pass through our Hades package called SQL Render, which will translate this particular dialect with its associated parameters into source database environments that you have. Now, throughout our community, we have talked about how we are trying to be technology agnostic and support as many databases that are reasonable. What many of you might not know and might be a new trick to be aware of is that the set of databases that we are supporting has continued to grow through community contributions. You can now see here that within Atlas, you can actually see that we have code from that will work against SQL Server, Microsoft APS, Oracle, Postgres, Redshift, Impala, Netezza, BigQuery, Apache Hive. While we don't encourage us to just build things to work for any database just for the sake of it, I think it's important to recognize that what we're trying to do is build solutions that will actually work across whatever data environment that you have. And we've been able to support a wide array of different technologies that we've seen across our community. And so for each of one of these, if you are a person who just likes to likes to ultimately just open up into an SQL console and write code, you can actually just grab any of this code, copy paste it onto your screen, and just open up a SQL console and be able to run it. There is nothing magic here other than the tremendous work of Chris Knoll and Anthony Senna and the entire Odysseus development team who've created this nice interface to allow us to design cohorts that basically allow you to point and click through without being a programmer to write pretty gnarly SQL, but queries that will handle all of the advanced use cases of defining phenotypes of interest. So I've taken you through that little navigation. I push generate, and if I scroll down, I don't actually know. It's being very laggy on my side. Now you can actually see here that the query has already completed. In about a minute, I was able to identify that there were 611,000 kids who were available in this Optum SES database who were observed on Halloween. So that could be a cohort that we can now think about studying and learning from, just as an example. If I click on View Reports next to a generation, this provides you the ability to look at the attrition table for your cohort definition. So you recall that I added an inclusion criteria. And sometimes what you're interested in is knowing what proportion of the people satisfy each of the inclusion criteria. So I actually started here with 12.2 million patients who satisfied our entry event, which was people who were observed in the database on Halloween who had the appropriate baseline and follow-up time. But you can see by applying that inclusion rule down in that second section, we can actually see that there were 611,000 patients who satisfied that criteria. That represented 5% of the population. And this other statistic here, the percent to gain, is a statistic that basically is telling you if you relaxed this particular criteria, if you were to remove it from your cohort, what percentage of the population would you gain back? In this particular case, we only have one criteria. So you can see that it represents 5% of the people, and we would gain 95% of the people if we were just to remove this criteria. Now, what some people don't necessarily use or are aware of is that there's a wealth of different statistics that are actually available in this report. To the right-hand side here, you actually see a tree map. In this case, this tree map's pretty elementary. We just have two boxes. There's a red and a green. But actually, if you hover over one of these boxes, you'll actually see that the statistics that are showing up right above the box actually move. And actually, if you hover over a box, you'll also notice that the text on the left-hand side is going to change colors. This box in green, you can see the text is black. And if I hover over the box in red, then the text becomes red. And what it actually tells you up top is how many criteria are satisfied or failed. In this particular case, with only one criteria, we're partitioning the database into those who passed and those who failed. Well, as you add more criteria, this gets to be a more complex set of combinations of criteria that you can actually explore. And while I don't see very many people in the community using this, it's proven to be a useful trick that's very helpful when you're actually considering combinations of criteria and you want to see how many people are satisfying it. And so in case you didn't know that trick, I just wanted to share that with you. All right, so I've created some sort of a cohort of people in Halloween. Now let's think about some other things that we could do. Now I had to create this cohort de novo because we didn't have one that was available. But remember, in the Odyssey community, we've already done a lot of development of other cohorts. And I share with you one of the concerns that's being raised, and we've had to have Dr. Fauci and the CDC come out and talk about how it is indeed safe to go out trick-or-treating, even though we've got COVID. Well, of course, as a community, we've been working a lot on COVID and have been creating various definitions. A trick that I bet not all of you know is how much good work has been going on within our phenotype development and evaluation work group to specifically develop and refine the ways in which one can define COVID-19 in observational data. And actually, the work that's been led by Gautam Rao, with a lot of support from various members of the work group, has now led to, where did I have it? Multiple iterations of our community exploring different ways to define COVID. And one of the specific apps that's available in data.odyssey.org/COVID phenotype iteration 3 is a cohort diagnostic tool that has run here 12 different variants of COVID definitions that our team has been exploring across different databases. And in the cohort diagnostic tool, the first tab here tells you about cohort definitions. So you can actually see all the different versions that our Odyssey phenotype work group has been using to explore COVID, whether it be by using diagnosis codes, using positive tests, or potentially removing people with negative tests. Now I'm clicking on one here, I don't want to pick here, C84, which just has this name, SARS-CoV-2 test 1 positive, or COVID-19 diagnosis with 1 positive or 0 negative in the 0 to 3 day window, 3 PCS 180 era. That's a mouthful and probably makes no sense to most of you, but that's just a label for the cohort. In cohort diagnostics, you can actually go explore the definition that is represented here, and you get human readable text. Now you might recall that I was showing human readable text on Atlas, and that's because in one of our Odyssey packages, CIRCE, which is actually our specification of our cohort definition, there is actually code that's available that, given a JSON expression of a cohort, will produce human readable text. So the thing you're seeing here in cohort diagnostics is the same thing you would see for this definition in Atlas, because we're using the same back-end foundational Hades packages underneath all of this. And whether you're using a web-based application using Web API to do this, or you're doing this stuff all directly in R, you're basically taking advantage of the same features. That might be a trick that you might not have known. Now, the other thing to note is I'm showing you that we've clicked on this particular concept, but I can also see that JSON expression. So that code that I showed you that we can make in Atlas is also just being rendered here as one of these entries in cohort diagnostics. So if you had looked or been part of the phenotype work group and seen a cohort that you really liked, you're like, geez, I really like that cohort. I want to bring it into my environment. Well, actually, all you have to do from cohort diagnostics is just copy to clipboard this JSON expression. And if we were to go up into Atlas, into your own local Atlas, you could create a new cohort definition. So I'll click New Cohort. And I'm going to go to the Export tab. I'm going to go to that JSON button that I showed you earlier. And all I'm going to do is I'm going to paste in the JSON expression I just saw from cohort diagnostics and click Reload. And when I click Reload, you will now see that the definition tab that's entered here is going to give me the information that was in that cohort definition. Now, this is a trick you might not have known because it's a little bit odd that you would import from an export tab, and that's like a long-standing groaning joke within our development group. But the point is that when we are using cohort definitions across all of our work, these are objects that are fully computable. We can pass them around, whether it be putting into a study package to run a network study, whether it be passing it from one institution to another through the Atlas interface, or by sharing and reusing materials from our cohort diagnostics. Not so sure how many of you knew that yet, but I wanted to share that trick just in case you weren't aware of how you can pull these objects in yourself. Now, when I loaded this one in, I want to highlight the particular logic that's represented here. As a community, we actually haven't used laboratory values too much. We've done an awful lot of phenotyping based on diagnosis codes, based on drugs, sometimes based on procedures. But COVID was actually the first time that across the network, we've actually been thinking a lot about trying to use measurement values, and particularly as those who received SARS-CoV-2 antigen tests, how do we actually take advantage of the values that may be returned? Now, many organizations, many of you might have data that actually doesn't have any measurement values at all. And so this might be a relatively new area for you. And then actually, in this particular definition of COVID that I'm showing you here, we have tried to work as a community to come up with a definition that will work even though you might have different types of data. This definition here is showing that you could either qualify for having a COVID event based on having a measurement of a SARS-CoV-2 test with a value as concept of either detected, positive, or present. Or you could qualify for this definition based on having a diagnosis code of COVID-19 and having exactly 0 SARS-CoV-2 tests with the value of negative, absent, or not detected within a 3-day interval relative to the diagnosis code. Now, this was actually a new discovery that we've had based on the hard work of Anna Ostropolitz at Columbia, who, as George highlighted at the Odyssey Symposium in our vaccine effectiveness work, dug into doing actual chart reviews of cases of COVID-19 that we observed post-exposure to a vaccine. And what was actually observed was that sometimes people would have a diagnosis, but that diagnosis might also be accompanied with a negative test. Maybe there was suspicion of COVID that wasn't validated, or maybe it was just the rationale for actually justifying the test. In any case, as a community, we're starting to evolve and develop a more sophisticated definition of COVID based on these empirical observations that we can gain. Now, one of the things I want to highlight that I'm thinking that not all of you may be aware of is that here we are using value as concept. These are concept IDs that can be representing different terms that may come along with a measurement value. In this particular case, you're seeing for our positive cases, we actually have 6 values here. There's 2 that just say the word detected, 2 say the word positive, 2 say the word present. And these actually come from our collection of vocabularies that we have that provide valid identifiers. And the reason actually we have those doubled up is because there are concepts from the SNOMED vocabulary and concepts from the LOINC vocabulary that we have observed to be used across our network. They're valid codes to use, but if one organization uses a LOINC concept for detected and another organization uses a SNOMED concept for detected, then we actually can run into a problem if we don't create a definition that accommodates both. The list of concepts that are available can be reviewed by just clicking the add button in that list and being able to see, to be able to basically search and look through. The thing that I would particularly reinforce here, though, is that just because it's available doesn't mean it's something we would expect to be across our network. And in particular, when you look at this chooser, you'll see that there's a standard field that says N and S, where S is representing standard and N is representing non-standard. And so one of the things that can be sometimes useful is if you are interested in looking only at standard concepts that you can just sort, or if I had searched for the word detected, I can type into this filter box and be able to see that I have a standard concept for detected, comes from the SNOMED vocabulary, and indeed this is one of the ones that we had to select there. Now, one of the little bugaboos about our user interface here is that you now see this word, but you don't necessarily know what concept you picked. And one of the little workarounds that I'll often do, if I didn't know exactly what these codes were, is I will actually go back to the SQL code that is actually underlying these cohorts. Because remember, while you were clicking through a nice user interface, all that's happening here is that we are just writing code that is actually being rendered on the screen to be able to show. Oops, I should have saved this first. We were doing a demo of this COVID events. I have to say, I've never given a presentation where my eyeball was being scratched by a mask before, so this is a good new experience. So let me just save that there.
And you still make it look easy, Patrick. That's the first part.
With one eyeball in pain, I'm going to still continue forward with this demo.
One eye, you can build a cohort. We knew it.
So in the SQL statement, remember that while you don't need to be a programmer to do this, you can click through your buttons, but remember that all that's actually happening here is that we are writing code. And so if you get comfortable with the OMOP Common Data Model, you understand the tables and the fields, it's quite easy that you can be able to look through and see things. For example, this statement here is just saying where measurement.value as concept ID is in this set of identifiers. And that can be helpful because now I've got a list of numbers that I possibly could use or reuse in some sort of future definition that I might want to use. And so if I go back here and let's see, I'm going to just to keep it safe or separate here. If I had created a new measurement, I could have said where value as concept ID, and then I could import. And here, if I have that comma separated list, I can import my comma separated list. And you can see indeed that that list pops up. I bet you all didn't know about that feature. It's a relatively new add, but it's been a lifesaver for me because sometimes I had to clickety-click through to make that long list of 6 things. And I was always concerned I might miss something. So this new import button allows you to pull in comma separated list of identifiers, which you can go easily find in your tool. All right, I'm going a little bit behind, so I'm going to go a little bit faster here. So I've created, so we've got a cohort of people on Halloween. We've got cohorts of COVID that I pulled from our community phenotype library. The question is, like, what can I learn about people with people on Halloween in our data set? Okay. And here I'm going to talk about how I can use our characterization tool in Atlas. One of the powerful features that's currently maintained by Anthony Senna in our community is a Hades package called feature extraction. And feature extraction is a tool that lets us characterize attributes or features about a particular population. And in Atlas, the characterization feature basically allows you to say, pick the cohort or cohorts you want to do, that you want to summarize, and then select the features that you would like to characterize. And so here I could do something like, say, select those people in the database that were on Halloween. That's that cohort I created. And then I could select any of a large number of features that I might want to summarize. You know, very commonly when we do our typical studies, we might be interested in things like if I search for demographics or select it from this drop down on the left-hand side, we can see that we have various characteristics like age and sex and race and calendar month. And so these might be attributes that I'm interested in, so I could select them. And by selecting multiple, I can just add them to my list of features that I want to run. But in particular here, I'm interested in like what happens to people on Halloween. So what's going on for their health? In which case, I can go ahead and I'll just remove those and say, maybe I'm interested in what conditions take place to people on Halloween. And I can see here that if I search for conditions, there's a large set of features that are just readily available in Atlas for you to select. Some of you who have conducted analyses of population level estimation studies or patient level prediction will recall that some of these are the covariates you would select from your model. They're the same types of variables available. But you could select any of these and add them. And here I've said condition group, era, start, short term. And in this particular context, our default setting of feature extraction would say, okay, you've selected this short-term window. That's going to be the 30 days before Halloween, and we could summarize what's happening to these people. But I might be interested specifically in what happens exactly on the day of Halloween, or maybe the day of Halloween or the day after in case something bad happened the day after that got recorded. One of the features that has been available in Atlas for quite some time, but I don't see very many people using it, so I think it might be another trick to highlight, is that in Atlas, you can actually specify the analysis parameters for the features. And so what are those parameters? It's actually a little bit hard to know, but if I just Googled OHDSI feature extraction, you can go out to our OHDSI GitHub repository and you can read all about the feature extraction package, which is has a nice git.io page here. And you can read about the various features that are available. There's a nice vignette that's in here, for example, that I'll just showcase and demonstrate quickly. Martijn did a great job of initially setting this up, and Anthony's been doing a good job of maintaining this so that we can use it. But if you were doing R programming, you would be able to see how you could actually call feature extraction. And I'm just going to scroll down simply to a simple part here. Let's see. Actually, I want to, let's see. Let me scroll up here. Where am I looking? This is target. This vignette explains how, as a package, standalone package in R, you could call the feature extraction functions to create and summarize the covariates that are available. What I'm gonna, that's actually not the one that I wanted, so I'm gonna actually go here. Just a short little thing here. I'm going back to Martijn's vignette here. You will see that there is a function called create covariate settings in the feature extraction package. And that basically is where all of the parameters for how you would call feature extraction live. And so, for example, you can see that there are parameters called like short-term start days and end days. And because all of the OHDSI tools in this ecosystem are actually working together in our Hades packages, these parameters are the same things that we pass into Atlas. So if I didn't want the window to be -30 to 0, I can actually just change the parameter. I can say, let's set the short term to be 0, and let's set the end day parameter to be end days to be 1. And if I were to set these parameters, basically what is happening behind the scenes is I'm now calling the feature extraction package, replacing the default parameters with these values, and then going to be able to perform the analysis as I want. I'm suspecting that this is a trick that many of you didn't know, because I've seen maybe 3 times ever where anybody has actually used this feature, but it can be very helpful in the case where you have some slightly customized approach that you want to take to performing an analysis, but it can be available for you. The other thing I'll just highlight on this interface that I don't see many of you use, so it might be a trick just to be aware of, is that you can actually perform subgroup analyses directly in a characterization. So for example, just like we would define an inclusion criteria in a cohort definition, we could say things like, well, I only want girls like Catherine, so I'm going to, again, sort on the standard column because I want to get to things that are standard. I can select my sex of female. I can add it to my list, and now I have defined that sex equals female is my subgroup analysis. In this particular cohort, I would now be saying find all of these kids who are in the database, but I also want to perform an analysis that subsets out kids who are female in the analysis, and the characterization tool is going to provide you both of those insights. All right, way behind on time, so I apologize for that, but I hope that maybe there's a couple tricks there that you all didn't know about to share with you. All right, what could we actually learn if we did perform such a characterization? I don't actually know if this is going to be done, but we're going to check one out. I ran one right before the start of this meeting. And we're going to see if it's actually done. What I did was I defined a couple different cohorts, and I'm reminded you that you could actually look at cohorts of people on Halloween, but you could also imagine if I wanted to have some sort of rough comparator, I might just take people who were in the database maybe 14 days before or 14 days after. Or I might want to think about what did Halloween look like in 2020 compared to what did Halloween look like in 2019 before the pandemic ever started. And so here I've got 4 different cohorts that I've created. I selected those features. I've played with our feature analysis, and I'm going to find out live here if this actually ran on any database. Suspense is wonderful. All right. I see that I've only got about half of you who've actually learned 3 or more tricks. So I got to get on my horse here to see if I can teach you more new things. All right. So here you can see all of our databases. There is an analysis that's been run on the Optum the SES database, which is a large claims database. I have not looked at any of these results, so we're going to try to learn some new treats together. One of the things I'm going to highlight here is that I've just popped up. I'm actually seeing that basically nothing shows up on the screen. And that might actually be a little bit confusing. I can only see this ER visit on the same day. But actually it's because in the top right-hand corner, there's actually a filter being applied to basically say what proportion of data do you want to show. You can actually change this to whatever you want, and since we're dealing with kids, we would expect most stuff to be rare, so I'm going to set that threshold down to 0%, meaning I want to see everything. And when I do see everything, now what you are seeing as a summary statistic is we're seeing the prevalence of all possible conditions, and I'm showing you a column for every cohort. So I've got on Halloween 2019, on Halloween 2020, and then I've got 14 days earlier in 2020, 14 days earlier in 2019. However many cohorts you produce, it's going to just stack that information side by side. And you can use this table to sort on anything that you may be interested in. Or you can also use the search to be able to filter to something. So we heard about motor vehicle accidents, so maybe I'm worried about that and I want to see how often that actually happens. So I just start typing vehicle there, and we can actually see that indeed we do see victim of vehicular and or traffic accident. It happens, though across our many, many hundreds of thousands of kids in this database, the number of observed traffic accidents is relatively small, less than whatever. Here we've got less 13 or less in each of these particular cohorts, and actually the frequency by which they happen isn't demonstrably different between Halloween or 2 weeks earlier. And so while we might be worried about traffic accidents, we actually can know that the absolute risk is pretty good as long as you just take care of your kids. So we could search for any particular concept there. When you have lots of cohorts to look at, it can be a little bit overwhelming in terms of results. One of the tricks that I like to use is to select just 2 databases and put them side by side. And so I'll just take 2020, so this last year in the pandemic, and I'm going to compare Halloween to 2 weeks before Halloween. And one of the tricks in the cohort characterizations is if you only select 2 cohorts, you can actually produce additional supplementary statistics. Namely, you can compute a standardized difference, which tells you about the prevalence of those 2 cohorts and whether or not they are different. And you also get a nice little bit of eye candy here, which is a plot that looks pretty awful in this case because the values are all extremely low. But I can actually sort based on the standardized mean difference to see what things are actually different. And here we can see for conditions, the differences in the occurrences of conditions on Halloween or the day after are very similar to the occurrences of conditions in kids 2 weeks before. And so in this particular case, we're not seeing a notable difference in any particular characteristic. All right, let's see. Now, I might be interested in how the Halloween of last year compared to Halloween of 2019 before the pandemic. And here, I can now see that there are starting to be more substantial differences. If I sort on the standardized difference, we can see that there are various conditions that are actually occurring much more commonly in 2019 than they are occurring in 2020. Now, this can be something that's physiologic, or more likely, this is just a reflection of how healthcare service utilization has changed over time. But again, without actually knowing the thing that I was particularly looking at, I can go actually identify these differences and observe them. And what's of particular note for any of these things is the absolute frequency of pretty much everything on Halloween is very low. And you are seeing, if I'm worried about things like poisoning from razor blade apples or anything, that the number of poisoning cases that we see are extremely low. If we looked at traffic accidents, we can see that that's extremely low as well. And so you can get a sense that the absolute risk for kids is pretty low, probably going to be safe. Okay, I got 4 minutes left, and I've got, let's see, I got 21 of you that 21% of you that 31% of you that haven't learned 3 new things. So let's see. So let's take a look at an incidence rate. Now, we saw that article that actually said that you got to be worried about COVID in a pandemic because you're going to walk around with kids outside, but our CDC is saying that it's safe and worthwhile to consider doing. I wanted to just highlight very specifically in the incidence rate tool, we could actually define an analysis to characterize the incidence of COVID. We could define multiple cohorts, like in this case, October 31st or October 17th, for 2 weeks earlier. We could define that cohort that we pulled out of the cohort diagnostics phenotype library, and we could look to see the incidence of COVID in a 7-day window. We can also stratify that analysis using the stratification feature. And again, when I mentioned that tree map feature is also available here in the incidence rate package. So here in this Optum SES database, we can see that we had 12 million people overall in 2020. We had 23,000 cases of COVID. But now by clicking on the drill down report, we can actually get the incidence rate with a univariable stratification of each of these factors. We can see for kids 5 to 11, the incidence rate was 0.8 per 1,000 persons. If I click these little plus minuses, I can just change my denominator to have a useful information there. But you can see I've got things like age and sex. Over on the tree map, if I highlight any of these buttons, the stratification criteria that are in black are those that'll actually tell you who I'm looking at. So in this particular case, this is females age 5 to 11, so that'd be Catherine. And that text above is actually telling me about the incidence rate. So I can see that indeed that the incidence rate is relatively low in relation to other particular subpopulations. Now, this is the incidence rate that I have for Halloween, but we could think about actually looking 2 weeks earlier to see what the rates are. And potentially we might be alarmed to see that it was 85 per 100,000 persons aged 5 to 11, and 2 weeks earlier it was only 50. So that can suggest that there could be a rise in cases. Well, if we looked at the CDC website, we'd be able to actually see whoops, sorry about that. 1 minute left, Craig. I promise I'm going to finish with a bang here. You can see that the rates of events is going up here. And so I'm not really sure that I'm going to call that Halloween was the cause of COVID so much as the third wave of COVID was the cause of COVID. But these cohorts that I've created, these incidence rates, all that's going on behind the scenes is data is being populated in your common data model, and you could just query that stuff yourself. So for example, if you were to just write an SQL query on your database, you would be able to say, go get me the people who are Halloween eligible with a simple SQL statement. Select star from cohort where cohort definition ID is your identifier. And you can go find the people that are the COVID cases. Select star from cohort where cohort definition is a number. And with this one query that I'm showing you here, what I've been able to summarize for you is for kids getting COVID, when does the COVID happen relative to Halloween? Halloween is day 0. You can see the events that were occurring for the 2 weeks prior to Halloween. And then you can see the events that are occurring afterwards. And what you do notice is that on day 2, 2 days after Halloween, you do see a slight uptick in the number of COVID cases that we observe in this database. Now, this is 100 cases amongst hundreds of thousands of kids. We're at noon, so I'm going to tell you that I believe Halloween is safe. I believe Halloween is a good thing that you shall do, but you need to make sure that you take care of your kids by making sure they don't eat razor blades, don't get peanut allergies, and try not to get COVID. But our data can actually help us understand what those absolute risks are. And in real time, you can perform these analyses in your own Odyssey tools to gain insights. And if you can do something silly like study what's the effect of Halloween, then imagine the questions that we can actually answer about real exposures and real outcomes and real issues that matter to all of us, in addition to wearing a Captain America Cheetah Unicorn hat. So with that, I will stop. I will ask you to vote one last time to tell me if you got 3 or more tricks that you didn't know about before. I've got 89 responses here. And let's see, I've got 14.
We just hit 80%.
Just hit 80%. There it is. 12 o'clock, 80% of you learned 3 or more tricks. So happy Halloween to everybody. I hope you all have a wonderful weekend. I look forward to seeing many of you in San Diego at AMIA. It's going to be a good time. No word on what I will wear for the induction ceremony, but it probably will be something that might mortify George just a little bit. Thank you all very much. Look forward to seeing you next week in November.
Thank you, Patrick. This was great. We will have the recording. There was a lot here, so we will get the recording up as quickly as possible on in both teams and the community calls webpage. Otherwise, everyone have a great week. Safe travels to AMIA. If you are going, we will be back next week doing breakouts. So hopefully, if you're out there, you can still make this call. Again, thank you, Patrick. Thank you, everyone, for joining. Happy Halloween. Take as many of your kids Reese's Pieces and Milky Ways as possible because they're the best ones.
Patrick, you'll be happy to know that issues have been filed based on some of your input.
Bye. Have a great week.
Bye, everybody.